Honors Algebra 2, Chapter 4, Section 8. This is the last section for solving quadratics. We have solved by factoring, square rooting, completing a square, and so now we're using the last method we'll talk about, which is the quadratic formula. And this is the method that works for all cases. So this is the quadratic formula. This is actual tattoo. It's just off of the internet, very famous for people to get tattoos of quadratic formula or other math formulas. So how could you find the roots here? So first of all, roots, what does that mean? Roots are the same thing as zeros, x-intercept, solutions. These all mean the same thing, factors. And so we could first see if we can factor this. And so if you try breaking this into two factors, it's not factorable. The next thing we could do is look at completing the square. If we want to complete the square, we would first need to divide both sides by -1 or factor that out. And so we're finding the 0, so this is really a 0 here. So I divide by -1, I'm getting 0 equals, and this just changes the sign of everything. And we have to do it here because we need an a value that's 1 to complete the square. And so now we're looking at what we can actually, now we would add 27 to both sides. So 27 equals x squared minus 2x. Now we can complete the square. What do we want to add to both sides? So we're going to add 1. Half of b is -1. -1 squared is 1. So we also need to add 1 to this side. So we get 28 equals x squared minus 2x plus 1, which now is factorable. So we have 28 equals x minus 1, the quantity squared. So we can square root both sides. We get plus or minus 2 root 7 equals x minus 1. We have 1 plus or minus 2 root 7 equals x. So that would be the solution, the exact solution. So that's one method that we talk about completing the square. Good review. We can also use quadratic formula to do the same thing. So we want to put 0 in for y again to find the roots or solutions. And to use the quadratic formula, we have to first realize what a, b, and c are in this formula. And so a is the leading coefficient still, b is the coefficient of x, and then c is the constant in the equation. This is standard form. We have the 0 on one side. It has to be in standard form to use quadratic formula to find a, b, and c. So we just plug them in. So x equals opposite of b. So our b here is 2. So we're going to do -2 plus or minus the square root of b squared. So we're doing 2, the quantity squared, minus 4 times a, which is -1, times c, which is 27. And that everything is divided by 2 times -1. And so when we simplify this, we want to simplify what's underneath the radical first. So this is going to be 4 plus 108. So 4 plus 108 is 112. So we have the square root of 112 over -2. And we need to simplify the square root of 112. So x equals -2 plus or minus. So 112 we can divide it by 16 actually, so it's like the same thing as the square root of 16 times 7. 7 times 16 is 112. It's still over -2. So this is x equals -2 plus or minus 4 root 7 over -2. Now we're dividing by -2, we're dividing both the -2 by -2 and the 4 by -2. So if we simplify that, -2 divided by -2 is +1. And then plus or minus, you really don't care about the sign here because a positive and a -4 divided by negative. So you're still going to have plus or minus. But 4 over 2 is 2 root 7. So this is the same answer we had in the previous slide. We're still solving that same exact quadratic, just using a different method, quadratic formula. And so quadratic formula works. You probably remember that from Algebra 1. But if completing the square is actually faster for a lot of these problems. And so again, we're looking for that coefficient of 1 in the even b value, then completing the square is really quick. And so I would not always use quadratic formula, but it's a method that always will work. So how to remember? Again, it's x equal -b plus or minus the square root of b squared minus 4ac all over 2a. So you probably heard Pop Goes the Weasel. There's another one I'll show at the end of the lesson that's actually more entertaining than me saying But you do need to have this memorized. I will not give this to you. And when you have this memorized, you actually have more than one formula. This part right here, you should recall, x equals negative b over 2a is part of the quadratic formula, and we should recall that as the vertex. And then you also have the b squared minus 4ac, which we'll talk about later on, which this is the discriminant. And so the whole thing is the quadratic formula, but you have three formulas in one. So we're going to solve this. First thing we want to do is subtract 15 to both sides. We have standard form. And then you could realize that you can divide everything by 3. I'm hoping you see that. Divide both sides by 3. So x squared minus 2x minus 15 equals 0. And so it just makes the number smaller, so we're using the quadratic formula. It's less mental math. So x equals negative b. So it's a negative negative 2, so it's really positive b. Plus or minus the square root of b squared. And a lot of times I'll simplify in my head. So negative 2 squared is positive 4. Minus 4 times a. A is 1, so I need to show that. Times c. All over 2 times a, 2. So I'll do some simplifying as I write out the formula to help me out. So 2 plus or minus the square root of. This is going to be 4 plus 60. So this will be 64 over 2. So this is x equals 2 plus or minus 8 over 2. Now because this was a perfect square, this is kind of a added tip, whenever you have the square root of a perfect square, this is called the discriminant again, the part underneath the radical. Whenever it's a perfect square, I could have factored this. So some of you realize that I could have factored this with a 5 and 3 to get the negative 2 or. But if you don't see that, it still works here. So we have a 2 plus 8, so we have two answers here. We have 2 plus 8 over 2, and we have 2 minus 8 over 2. We have two answers. So we have 10 over 2 or 5, or we have negative 6 over 2, which is negative 3. So those would be two solutions. And again, here we could have factored this. X minus 5, x plus 3. So I'm hoping that you see the factoring first. I would much rather factor this problem than go through the work of quadratic formula. So on your quizzes and tests, when I say use the best method, I'm hoping you see factoring as the best method for a problem like that. So I'm going to have you try this one on your own. This is your homework problem, homework video problem. So turn that in when you walk. Following objects we're going to talk about tomorrow. But let me just introduce the formula for that. The height of an object at any time t. So h of t, again this is like our y value. So the height at some value t is equal to negative 1/2 times g t squared plus v0 sub 0 t plus h sub 0. And so that's kind of a famous physics formula for the height of object. It's a vertical motion up and down. Anything that's going up or anything that's get pulled down uses this motion, where g is gravity, t is time, this is the initial velocity, and then the initial height. And so we'll do some examples of this in class tomorrow, knowing that this formula is one I'll give to you now, but it's one you should become comfortable with in the future math and physics classes. So the discriminant, here I mentioned about this a little bit. It's the part of the quadratic formula that tells how many solutions the problem has. It's the b squared minus 4ac, the part underneath the radical sign here in red. The number of solutions that a quadratic equation has. When you have it in standard form, when you find the discriminant, if the discriminant is positive, then the equation has two real solutions. If the discriminant is 0, there's one solution. And if it's negative, there's no real solutions. Or you could say there's two non-real, because these right here actually become imaginary, non-real, so you end up starting dealing with the i's again when you have the discriminant being negative, because you have the square root of a negative value of that. Here the square root is 0, because when you have plus or minus the square root of 0, you're only adding and subtracting the same number, so you only have one value. So those are three different possibilities. I want to see this graphically so you can see how if you have a positive discriminant, we have two solutions. That's because our graph crosses the x-axis, which are zeros or roots, twice. If it's negative, we have no solutions because a parabola here doesn't cross the x-axis. Then 0, we have one solution. That one solution is when the vertex is the x-intercept. And so those are the three different possibilities here. And so we can take some of these equations here. Let's just do one of these. Let's do the more interesting one here. And let's find the discriminant for that. So this is part B down here. So it'd be b squared, which is 16, minus 4 times a, which is negative 3, times c, which is negative 5. And so you have to evaluate this. So this is 16. This is going to be minus 4 times 5 is 20. 20 times 3 is 60. And so we have 16 minus 60. And so we end up getting a negative 44. And so because the discriminant is negative 44, so the equation has two non-real solutions. And so if you're finding the discriminant to find how many solutions you're going to have, you're going to be using the quadratic formula to find the solutions, because you're almost done. You found the radical portion, so you're mostly done solving. So we're going to call it good, except for I'll show you a little video here. Fun way to end.
2 to a hang low under negative b plus or minus square root b squared minus 4ac. If you practice that quadratic, you find know it automatic. 2 to a hang low. Are these corrects? Cause these numbers that I got are too complex. So imaginary you can see without your specs. Wanna know what's next? Yeah. Take out the I if you want to make complex numbers easy, just simplify. You can add, subtract, divide, or multiply. Then there's the discriminant. And there's 3 ways to classify. If D is greater than 0, then 2 answers are justified, and you get the answer right, and you are glorified. If D is equal to 0, there is one real root. If D is less than 0, that's when we start to get confused. Are these correct? Cause these numbers that I got are too complex. So imaginary you can see without your specs. Wanna know what's next? 2 to a hang low under negative b plus or minus square root b squared minus 4ac. If you practice that quadratic, you can know it automatic. 2 to a hang low. Stop.
Stop it there, but let me give them credit. Quadratic Rap. This is done by these two people, Adam and Braley Branson. So you can look them up on YouTube if you want to watch more of it. Have a good night.